Hi everyone, this section is taken straight from one of my live streams where I used some easy analogies to explain virtualization. It's a unique way that helps you unpack the concept and mechanics behind it, so enjoy the video guys. So before we dive in, let's clarify what virtualization really means. Um, it's important you know that I just do this very quickly. So imagine you have a computer, like a powerful machine, a single computer like this one. Let me see, laptop. Let's take that one, and let's say like it's a very powerful machine and it has a lot of RAM, a lot of CPUs, etc. Now imagine dividing this one machine into smaller one, like this one. In my case, I have, for example, 3 VMs. Okay, I have 3 virtual machines, but they are like independent, isolated, and they they have their own, like we allocated their own RAM, own CPU, etc. So guys, that's virtualization basically. That's virtualization. And now, so I think like most of you they know about that, but I'm just gonna talk about the a key misconception is that resources, many people think that resources are fixedly divided. For example, if you assign 4 GB to 5 virtual machines, so it means 20 GB, on the computer with only 16 GB of RAM, it doesn't mean that your computer actually and like strictly locks in 4 GB for each VM. So it means that in my case, for example, let's maybe take 5, okay? Because I have in my laptop I have 24 GB. So sorry, the count doesn't add up. It doesn't add up. Let's just stay with 16 GB. Imagine I have 16 GB and I have 5 laptops. You see, it doesn't fit in. The fifth laptop doesn't fit in because I have only 16 GB, so I can only support 4 GB and the rest, so it will be 4 multiplied by 4, 16, okay? But then this one I could not fit in. The thing is, it doesn't work that way. Okay, it doesn't work that way. Instead, the allocation is dynamic. Resources are only used as needed by each machine. So if you want to see the actual representation of what virtualization is and how your VMware act, it's like this. Like it go up, go down, go up, go down, go up. And it depends on how much you are using it. For example, guys, let's imagine this, like my case, the representation of my actual laptop. I have 3 VMs right now. You see DC2 router, DC1 site 1, etc. Let's say right now, because I don't use them, they look like this. And by the way, I have 24 GB of RAM. Okay, I have let's not use it because it would bring more it would be a bit more confusing for me. um I have 24 gigabyte right now on my laptop. So it means that a correct representation will be this one. And the other one, and maybe let's say the DC2, I'm using it right now. Like I'm using a lot of my DC2. I mean, okay, not DC2 but DC1. Let's say DC1 because I'm going to like Google Chrome, I'm doing a lot of stuff. So sorry. So this DC1 will be like a little bit bigger than this one. And now because I'm using much more my laptop, so let's say my laptop is here, my real laptop. Let's say we will put it like red because it's my real laptop. He's consuming much more than those ones. okay? But maybe I will then consume a lot of more about my DC2. I will use more my DC2. So then this one will be active and this one will slow down because I don't use it. I don't use my DC1 for the moment. So that's why, guys, you can fit more than what you locks, than what you give to each of your VM. But you don't locks 4 GB on your actual RAM, on your actual bar RAM. So let's say here it's your RAM. You don't lock 4 GB for each of your RAM, okay? You don't do that. Actually, I mean, in reality, you are dynamically giving 4 GB depending on your use. So yeah, so guys, I'm just saying this, and I have like one good example, sorry, analogy that I really love when talking about this. It's to avoid confusion. Many people think virtualization divides resources rigidly, like cutting a pie into fixed slices. That's the thing. Many people, they confuse it and they think that we are really like, if you have a pie and here it's your RAM, here it's the RAM. People think that we are like giving slices, like pie slices, and we giving this to each VM. This one is for him, this one for him, and this one is for him. But it's not true. It's not the correct way of seeing virtualization. The way of seeing virtualization, it's more like a buffet. You need to think of it like a buffet. You have food available, which are the RAMs. So it's like you have that. Let's make let's choose, for example, this thing. And it's exactly this way, guys. It's exactly like you have a buffet. And here they are the VMs. Like the people that you see here, they are the actual VMs. They are the actual VMs, and they consume what they need for the moment. For example, this guy is very hungry, so he will use like 3 GB, okay? And he have maximum capacity of taking 4 GB. So, and for example, this little girl, she's not that much hungry, so she will only take a little bit of vegetables, so a little bit of RAM, a little bit of CPU. So it would be maybe this one. It will be this virtual machine. So, but maybe this one will be very hungry after, and then she will use a lot of a lot of food in the buffet. Okay, so I like this analogy because it make things a little bit clearer. So let me wipe this up, and we're just gonna talk now about hypervisor 1 and hypervisor 2. I know that in the beginning, uh, many people, they had like some struggle with this definition. It's actually more about remembering the differentiation between hypervisor 1 and hypervisor 2. So it's what we will say here. So guys, hypervisor 1, the way that I remember it myself is, I say that type 2 hypervisor, it's, by the way, hypervisor is just like the technology. So you have like, in order to virtualize, to enable virtualization and work with virtualization, you use a type 1 hypervisor or a type 2 hypervisor. And the way that I try to remember it is, type 2, despite it's high, like the number is high, but it's for cheap. It's for cheaper people. How can I say? It's cheap. Yeah. Even though the number is high, it's not expensive, but it's cheap. And hypervisor, as you know, it's VMware VirtualBox, so it's free alternative. And the hypervisor type 1, even though it's only one, it's the expensive, it's the one that is the most expensive. It's just my way of like my workaround to always remember the difference between type 1 and type 2. And type 1, of course, you know, guys, it's, for example, Microsoft Hyper-V, which I really love it, or VMware SKey. And what is now the differentiation between those two in terms of the concept? So type 1 hypervisor runs directly on the hardware without an intermediary, uh, without an operating system. It runs directly on the hardware. And type 2, it's the opposite. It runs on top of the OS, like Windows, like myself. Here, you see me, I'm using my OS, and on top of it, I'm using VMware, which hosts another Windows. But in the type 1, you actually directly run it on top of the hardware. So there is no Windows. So guys, I think you understand. It means that the type 1 is very efficient. Um, the the way that I like to also put it is, you know, guys, about okay, no, let's not take this analogy. Maybe this one is better. Okay, you need to imagine type 1 hypervisor or like an airplane's autopilot system directly flying the plane. So it doesn't need anybody. It use directly all the hardware components and the data to function, and he will act upon the data. He will see the data, how they act, what is the math, and he directly gonna act regarding the data. The type 2 hypervisor, on the other hand, are like a co-pilots who constantly checks with the pilots before making decisions. So you can imagine now why the autopilot is faster and more reliable. Because if something happened, the copilot would have to, I don't know, for example, wake up the pilot and say, do you think we should do this and that? And the pilot think, he look at the monitor and he said, okay, yeah, you can do this. And then the copilot will do this. Whereas for the actual type 1 hypervisor, which is the autopilot system, he will directly take action. So that's why it works very well for company working, real working environments. And the on the opposite, VMware, so type 2 hypervisor, it's very convenient for people like us who wants to experience stuff, who want to break things and repair and do and troubleshoot and do all of these things. Okay, so now let's talk about container versus virtual machine. Again, very briefly, we're going to cover this very quickly. So guys, VMs, each VM includes a full OS and application dependencies. This make them isolated but resource intensive, as you could. So because you see here, I have it consumed 2 GB. I did nothing. I'm doing actually nothing here, and it consumed 2 GB. Same for the router, same for the DC2. So by the way, let me plug this. Let me connect to my environment. So it means that it's very resource intensive. So just I'm doing nothing and it already consumes 6 GB, and I only have 3 GB active right now. So if someone have an 8 GB RAM, it's going to be impossible for them to make this work. Whereas a container share the host OS, and it make them how can I say, it's making them lightweight and faster to deploy. You see how much actually you weren't here because I prefer to launch it before to start a live, but it really takes really much time to launch the DC2, especially that my DC2 has the FSMO roles, so the master roles of all the lab environment. Same for the DC1. It really take a lot of time. And maybe if I could show you here this thing, and I think you will really like it. Let's say container. Yep. So guys, simply you just need to know that the actual VMs, it's this one. It means that you have the hypervisor here, and you have the guest OS. Okay, so let's say for example here it's the type 1 directly implemented to the hardware. So you have the hardware, here the hypervisor, and then you launch whatever host whatever OS you want, Linux, Windows, what you want. And then app 1 is for example Visual Studio Code, or I don't know, some apps that software developer use. And why I'm talking about this, it's because container, it's actually a lot for those people. Software developer use a lot of container. It's not our case, but it's just a way of explaining things, so you could have just a global idea of what container engine and the system, how it works. So you have the operating system instead of the hypervisor, and it control everything. Like it control everything. So as you can maybe already understand, it's less secure and less isolated. So yeah, maybe I could talk about that, and I could say, like, just as an analogy, imagine a VM as renting an entire house, while a container is like renting an apartment in a building with shared infrastructure like water, electricity, etc. And your VM has like the entire house for him. So what can I don't want to say this because it will not be fit to this analogy, but yeah, I'm just gonna stop it here. Like, I'm just gonna stop my analogy here, because I want to say stuff that are not quite true. Okay, no, that's actually true. The analogy could be good because when you have an apartment, you directly have warm water. You see, when you are in an apartment with a big building, warm water come quickly. But when you are in an entire house that you manage on your own, and you buy a house, warm water come very slowly. You have to wait. Okay, I made a good point. And it's exactly what happened here. What's happened here? I had to wait so much time for my DC2 to be on, and my DC1 to be on, so I could, have my OS display. And it's exactly like in my analogy, when you have to when you're when you open the when you how you say in English, um when you just yeah oh let's just say open the water, it will take so much time with when having a VM, so having an entire house. Okay, guys, so I hope this analogy was great. Let's now talk about VMware. So VMware, it's one of the most widely used virtualization tools. I highly suggest you to start with VirtualBox, because VirtualBox it's a mess. Like, to be honest, it doesn't work well. VirtualBox doesn't work well. There's so much issue. I don't know why, but I keep having I had so much networking troubleshoot to do, and at the same time my image was corrupted very easily. I don't know why, even though I still have this problem on my DC on VMware, but the difference is crazy between VMware and VirtualBox. But I still advise you to start with VirtualBox, because it will give you the foundation of troubleshooting stuff, understanding what's the IP subnet, how the how networking system work in a global in the global, like, just having a bigger picture of it, like an overview. Okay, so yeah, so if you are really a beginner, I will highly suggest you to start with VirtualBox and then going to VMware. So let's talk about the big misconception about the VMware interface. Let's start with the ribbon at the top. I see many people. I had, we had like many people that have this confusion that if you start doing things here or everything here, you are affecting these rebounds here, you are affecting every VMs. But it's not true. When you are, for example, if you are modifying things here, yes, you are touching to all of your VMs. But when you are actually setting stuff here, it's only to your virtual machine, not to all of the virtual machine in your lab environments. So yeah. Also, one thing that I want to add, the one that is quite interesting is this one. What do you think this is? Reserved memory.